Okay, we're looking at adding and subtracting fractions. And we're going to use the traditional method. So I've got the steps here, so let's be reminded. Remember, to get like denominators, if little goes into big, you're going to keep big. If we can't use this method, then we're going to use a T-chart to find the least common denominator. Step 2 says we're going to divide down, multiply up. Step 3 says we'll solve what we have. Step 4, we're asking, is it improper? And step 5, we're going to make sure it is in simplest form. And we're going to use factor trees to do that. All right, let's look at number 1. Let's get like denominators. We want to add these. We can't just add them like they are because they have unlike denominators. Now, the first method is if little goes into big, we're going to keep big. Will little go into big? No, it won't. So we can't use that method. So we're going to use a T-chart to find our least common denominator. And this is what I mean by a T-chart right here. I'm going to put my 4 here and my 6 here. And I'm going to do the multiples of 4, and I'll do the multiples of 6. I'll do a few of the 4 and then a few of 6. We're looking for the first thing that they have in common. That's why it's called a least common multiple. So let's say 4, then 8, then 12. Oh, I know if I'm counting by 6, I'll say 12. 6, 12, there it is. Now I could keep going and I would eventually say 24. But I don't want to use those larger numbers. I want to use the lowest one that they have in common. So here it's the least common denominator. I'm going to now move this 12. Here it's a multiple. It's the lowest common multiple they have. When I put it here, it becomes the lowest common denominator. So I've got my denominator, and now I'm going to do my little strategy called divide down, multiply up. That means I'm going to take my denominator and divide it into the 12. 4 will go into 12. See, I'm dividing down. Divide down. 4 into 12 will go 3 times, and I put me a little tiny 3 there for my answer. And now I'm going to multiply up. 3 times 3 is 9. So I just renamed 3/4 to 9/12. These are equivalent. Now I'm going to divide down, multiply up on this side. 6 will go into 12, 2 times, multiply up, 2 times 5, go to the very top, is 10. Third step says solve. So that's 19/12. Now look at number 4. It's asking me, is that improper? Is it? Yes, it is. So I have to fix that. To fix that, this is actually, we've got a larger number on top. That's why it's improper. So this is actually, this fraction bar means we're going to divide. This is 19 divided by 12. So 19 goes inside and 12 outside. 12 is my divisor. 19 is my dividend. 12 won't go into 1, but it'll go into 19 one time. 1 times 12 is 12. Subtract. That's 7. I'm going to stop and rock. 1 and 7/12. 1 and 7/12. Notice how I made sure this fraction was as tall as the whole number. That helps us to read it better. Now that I've fixed it from being improper, I need to make sure it's in simplest form. And to do that, we're going to do a factor tree for each one of these, for the numerator and the denominator. Now 7. I've got to decide if it's prime or composite. Remember, we've talked about this. Your primes, your lower primes are 2, 3, 5, 7, 11, 13, and then we go on. We've got, there's many more, but we'll stop there. So we know that 7 cannot be factored, so I'm going to circle it. Now I'm coming over to 12. 12. We know we could say 2 times 6. We could say 3 times 4. It doesn't matter. But remember, we never want to say 1 times something. That's why we're circling 7, because the only thing we had to do 7 with was 1 times 7. That's why it's prime. So 12, let's do 2 times 6. We know 2 is prime. See, it made our list over here. 2 is prime because the only way I can make 2 is 2 times 1. So now let me do 6, and that'll be 2 times 3. And those are both prime. Now I want to stack these. And since 7 is my numerator, everything that I circled for 7 goes on top. 12 is my denominator. Everything I circled for 12 is on bottom. Do I have anything I can cross out? It has to match on top and bottom. I don't have any matches, so that tells me that there's nothing else I can do to this. I'm going to make sure I circle it. It's my final answer, and I'm moving on. Number 2, we've got 2/8 plus 1/2. Now, starting over with my steps, I've got to get like denominators. If little goes into big, keep big. Well, let's look. 2 is my little number. 8 is my big number. 2 will go into 8, so I get to keep 8. I like it when I can keep it. It makes it a little quicker and easier for me. Step 2, divide down, multiply up. Bottom number into bottom number. 8 will go into 8 one time. Multiply up. That means I'm going to multiply this number times the very top. 1 times 2 is 2, and it goes on this line. So see, the 2/8 stayed the same. Now I'm coming over, divide down, multiply up. 2 will go into 8, 4 times. 4 times 1 is 4. See, we renamed 1/2. We put 4/8. These are equivalent fractions. Now I get to solve 6/8. It's not improper, so I can move on to the next step, number 5, simplest form. So simplest form, remember, we're going to do a factor tree for each one of these. 6, 2 times 3. We know the 2 is prime. The 3 is prime. Let's go to 8. We'll do 2 times 4. 2 is prime. We'll branch 4. 2 times 2. Okay, I'm going to draw my line. I'll put everything I circled for 6 on top. 2 times 3. Everything I circled for 8 on bottom. 2 times 2 times 2. Oh, I see a match here. That 3 doesn't match with anything, so I'm done. So the 6/8 will now be renamed to, there's only a 3 on top. So I'll keep my 3 there, and I take the 2's and multiply them together. 2 times 2 is 4. So the final answer is 3/4. All right, let's move on to number 3. We've got 3/4 plus 2/8. All right, I went ahead and set it up because I know I've got to get like denominators. If little goes into big, keep big. Oh, I'm in luck. 4 does go into 8, so I get to keep 8. Now I'm going to divide down, multiply up. 4 going to 8, 2 times. 2 times 3 is 6. 8 will go into 8 one time. 1 times 2 is 2. Coming over, solve it, 8/8. And we know that anytime we have the numerator and denominator that are exactly the same, that equals 1 whole. There's nothing else we can do to it. We don't have to worry about steps 4 and 5. Once we get 1 whole, that fraction is finished. Now, if I'm going too fast for you, just just pause the video. I'm sure that you have to pause anyway to write your problems and things like that. But if you have any problems somewhere, if you got a spot you don't understand, maybe you could pause the video and highlight that or circle it and reach out to me, and I can try to help you with it. All right, let's look at this one, number 4. We got 4/12 plus 3/4. Okay, I'm going to go ahead. I know I'll need to rename these to get like denominators. All right, Remember, one of my strategies is if little goes into big, keep big. 4 does go into 12, so I get to keep 12. Now I'm going to divide down, multiply up. 12 will go into 12 one time. 1 times 4 is 4. See, 4 twelfths just stayed the same. 4 will go into 12 3 times. 3 times 3 is 9. Coming across, I'm going to keep my 12. 9 plus 4, 9, 10, 11, 12, that's 13. So I've got 13 twelfths. I don't know why I rewrote that, but I did. I've solved it. It is improper, and we know to fix it from being improper. This reads 13 divided by 12. The top number goes in. It's my dividend in the den, and 12 is my divisor at the door. Okay, we're going to divide this. 12 will go into 1. It won't, so I put a 0. 12 into 13. 1 time. 1 times 12 is 12. Subtract 1. We're going to stop, and what I call rock around the clock. 1 and 1 12. And I already know that that is in simplest form. Anytime we have a fraction with a 1 as my numerator, it's done. There's nothing else to do with it. We'll circle it and move on. Now, those are 4 problems that we did using addition. Now I'm going to turn over, and my next problems will involve subtraction. We'll follow the same steps. So just keep moving with me. If you need to pause, feel free to do so. We're getting like denominators. Don't forget, we're subtracting this time. Little goes into big. 6 will go into 12, so I get to keep 12. Now we're going to divide down, multiply up. 6 will go into 12, 2 times. 2 times 5 is 10. 12 will go into 12, 1 time. 1 times 7 is 7. Coming across to solve. 10 minus 7 is 3. I'll keep my 12. It's not improper. And by the way, I just solved it, so it's almost like that step just comes natural. It's not improper, so now I need to put it into simplest form. So I'll take my 3. We know it's prime, so I circle it. I'll go to 12. 3 times 4. 3 is prime. Let's look at 4. 2 times 2. Prime, prime. Let me draw my line. It's a big, long fraction bar. The number I circled for 3 is just 3. And the numbers I circled for 12 are 2 times 2 times 3. I match my 3's up. And I look at what I've got left. Since I don't have a number left on top, we say that it's understood to be 1. When you don't see anything left up top, you use 1 as a numerator. On the bottom, I've got 2 and 2, so I multiply them. 2 times 2 is 4. So my final answer, 1/4. All right, number 2, we've got 3/4 minus 4/12. Okay, use 12 as my denominator. Because little goes into big, right? We're going to divide down, multiply up. 4 will go into 12 3 times. 3 times 3 is 9. So we just renamed 3/4 to 9/12. These are equivalent fractions. 12 will go into 12 one time. 1 times 4 is 4. 9 minus 4 is 5, and I'll keep my 12. I solved it. Is it improper? No. So let's make sure it's in simplest form. So I'll put my 5. I don't have to branch it. It's already prime. Here's 12. I can say I could do 2 times 6. I could do 3 times 4. I'll do 3 times 4 this time. 3 is prime. 4. 2 times 2. Prime, prime. Draw my line to stack them. The numbers circled for 5 go on top. The numbers circled for 12 go on bottom. 2 times 2 times 3. We don't have a match, do we? So that tells me that 5/12 is already in simplest form. And the reason I always circle my answer is because I've got so much work. Circling the answer makes it stand out better. Okay, number 3, 4/3 minus 5/7. Notice that's already improper. But oh well, we'll go with it. Okay, we've got to get a new denominator. Little goes into big. Will 3 go into 7? Not evenly, so I can't use that strategy. I'll need to use a T-chart. So I'll come right down here and use me a T-chart with 3 and 7. So let's go 3, 6, 9, 12, 15. Let me try 7. 7, 14, 21. Okay, let me get a little higher here. 15, 18. Oh, 21 there. Okay, good deal. So 21. Now, some people say, well, we could have just multiplied those, couldn't we, and get 21? You sure can. You can multiply your denominators to get a denominator down here anytime. But oftentimes, it may not be the lowest denominator that you could use, and that'll make you have a larger number to work with. For instance, look at number 1. If we had said 6 times 12, we could say 72. We would have had to use 72 down here. And that's a big number to work with. So by being able to if little goes into big, keep big, that helps us stay in check. And also, sometimes using these T-charts can help us keep from using a number that's too large. So let's divide down, multiply up. 3 will go into 21 7 times. 7 times 4 is 28. So they're saying 4/3 is equivalent to 28 over 21. Notice it's still improper, but that's okay right now. All right, we're going to divide down, multiply up. 7 are going to 21 3 times. 3 times 5 is 15. Now we've got to come across. We're going to keep the 21, and I've got to subtract. I'll subtract my ones place, 8, because this looks like I won't have to do any borrowing or anything, so it looks pretty cut and dry. If you could also come over and do this if that helps you better. 8 minus 5 is 3, and subtract my tens place. 2 minus 1 is 1. So we've got 13 over 21. Now I'm going to do a factor tree for this. 13, we know that is prime. When we were counting a while ago, remember did we get to 13 already? Yeah, 13 was the last one we listed. And then we could go on and say 17 and then 19 and so on. So they keep getting higher. Okay, sorry, chasing rabbits. Okay, now I'll do 21. Factor that out. 3 times 7. Prime. Now let me stack them. 13 on top. 3 times 7 on the bottom. Do I have any matches? Now somebody might say, yes, the 3. Well, this is 3 by itself. This is not 3 by itself. This is 13. So you cannot match these. So I do not have a match. And remember, when we don't have a match, that means our answer is already in simplest form. Okay, let's go to number 4. 3/2 minus 5/6. Go ahead, rename it. Will little go into big to get a new denominator? Will 2 go into 6? Yes, love it. So we'll keep 6. Divide down, multiply up. 2 will go into 6 3 times. 3 times 3 is 9. 6 will go into 6 1 time. 1 times 5 is 5. Come across. 9 minus 5 is 4. Put my 6. It's not improper, so I need to put it into simplest form. The 4 will say 2 times 2, prime. The 6, 2 times 3 prime prime. Draw my line. The numbers for 4 will go on top, 2 times 2. The numbers for 6 on bottom, 2 times 3. I'll match these up. And look what I've got left. I'll just take, since there's nothing to multiply this with, that is my final answer, 2 thirds. And I'll circle it. Okay. I hope that this has helped you gain a better understanding of adding and subtracting fractions with the traditional method of finding a common denominator. If you need any help, please reach out to me. I hope you have a good day.